Hello, welcome to chapter 2.3. In this chapter we're going to learn about the Babylonian number system. Babylonian numeration. The ancient Babylonians used a modified base 60 numeration system. The digits in a base 60 system represents the numbers of ones, the number of 60s, and the number of 3,600s, and so on. The Babylonians used only two symbols to create all their numbers between 1 and 59. They used this symbol for 1 and this symbol for 10. This is how the Babylonians wrote 4,856. How we interpret this using our two symbols? Well, 1 times 60 squared is 3,600, and we use the symbol for 1 here. Plus 20 times 60 to the first power is 1,200. So here's our 10, 20. So we use two of them because 2 times 10 is 20. And that is now in the 60s place. Then we have 56 times 60 to the 0 power, but as we recall, anything to the 0 power is 1, so we just represent it by 56. So it's 5 tens, 1, 2, 3, 4, 5 tens, and 6 ones. 1, 2, 3, 4, 5, 6 in the ones place. And this is equal to 4,856 in our base system. In example 1, we're asked to convert this number in Babylonian into our number system. So let us go over to the whiteboard and work this out in detail. Here we are asked to convert Babylonian into our usual base 10 system. Now the space between the sets of symbols indicates a separate place value. So this is one place value and this is another place value from the other symbols. So as I mentioned, here's one place value, here's another place value. And this place value is 60 to the 0 power. And this place value is 60 to the first power. Now since we have here, where this symbol, this is equal to 1, that means that this is 1 times 60 to the first power plus, and since there are two of these, that means this is 2 times 60 to the 0 power. And as we studied earlier, 60 to the first power, that means it's 1 times 60. And then anything to the 0 power is 1, so that means that it's plus 2 times 1, and that will be 60 plus 2, so our final answer is 62. Reviewing what I just did on the whiteboard, the space between the sets of symbols indicates a separate place value from the next two symbols. So this symbol was base 60, and we use 1. And here we have 2. So here is the 60s place, and here is the 1s place. So that means in the 60s place we have a 60,
And in the ones place, we have 2. So 60 plus 2 will give us 62. In example number 2, we're asked to convert 123 into Babylonian. So let us go to the whiteboard and work this out in detail.
In this example, we're asked to convert 123 into Babylonian. So what I'm going to do is I'm going to make a table like we did with our other bases before, except I'm going to do it in base 60 to see how far I go. So 60 to the 0 power, I'll put 60 to the first power and 60 squared. Let's see how far I have to go. Well, 60 to the 0 power, anything to the 0 power is our ones place. Anything to the first power is itself 60, and then 60 squared is 3,600. Well, 123 is far less than 600, so this one we do not need. So now on the side, I'll put 123, and I'll divide it by 60. And that means we have 60 goes into 123 2 times, with a remainder of 3. Since 123 minus 120 is equal to 3, and that 3 will be our remainder. So that means we have 2, remainder 3. And then in our last column, since 3 divided by 1 is 3, we have 3. Now remember, in Babylonian, each of the spaces is a place value. So if this symbol is equal to 1 and we have 2 of them, well, we'll have 1, 2, and that will be 2 times 60. And then we add, I leave a space here, and then we add 3, 1, 2, 3, because that will be 3 times 1, and that will give us our final answer, and that will be 123.
In reviewing what we just did on the whiteboard, we divide 123 by 60 in order to get 2 with a remainder of 3. So that means that we put 2 ones in the 60s place, and we put 3 ones in the ones place. And that means we have 2 times 60 will give us 120, plus 3 times 1 will give us 3, so 120 plus 3 is 123. In example number 3, we're asked to convert 683 into Babylonian. So let us go over to the whiteboard and work this out in detail.
In this example, I am asked to convert 683 into Babylonian. Now I already know that 60 squared is way too high. So I know that I don't need that place. So I can make my table fairly simple by just having 60 to the 0 and 60 to the first power, because I know 60 to the 0 power is my ones and this is my 60s. So on the side, I'll work it out. So I have 683, and I'll divide that by 60, and I get 11, and I work it out to get a remainder of 23. So this will be 11 remainder of 23, which I'll put here because that will be my ones. Now, as mentioned earlier, each of these columns, this line will represent a space. Now in Babylonian, remember, this will represent 10 and this will represent 1. These are the only symbols that we are interested in here are the 10s and the 1s. So 11 is made of 1 10 and a 1. And then we leave a space, and 23 will be made of 2 10s and 1, 2, 3, 1. So this is a 10, and this is a 1. This is a 10, a 10, a 1, 1, 1. So, but this is going to be multiplied by 60, so this 10 plus 1 is 11 times 60 plus 10, 23 plus 1 time plus 23 times 1. So 11 times 60, well, that will give us 660 plus 23. And our final answer will be 683, which is what we want. So that was just a little bit of check to make sure that we did that correctly.
Reviewing what I just did on the whiteboard, to make the number 683 into Babylonian, we divide 683 by 60 and we get 11 with a remainder of 23. And 23 will be put in our ones place and 11 in our 60. So here we have 10, 11, and 10, 20, 1, 2, 3. So 11 is in our 60s place, and 11 times 60 is 660, plus 23 times 1 is equal to 683. In example number 4, we're asked to convert 3,670 into Babylonian. So again, I'm going to go over to the whiteboard and work this out in detail.
In this example, we're going to take actually a very large number, 3,670, and convert it into Babylonian. Now here we will need the 60 squared because this is over 3,600. In this example, we're going to take 3,670 and convert it into Babylonian. Now here we have a very big number. And in this case, let's look, 60 squared. Well, remember 60 squared is 6,600. So we see this is bigger than that. So in our table, we will need to go a little bit further than we did in our last example. So we'll have the 60 to the 0 power, yes. We'll have the 60 to the first power, yes. But then we'll have the 60 squared. And remember, the 60 squared is 3,600. The 60 to the first power is 60, and anything to the 0 power is 1. So we can see, just by looking at it, that 3,600 goes into 3,670 one time with a remainder of 70. So let's look into the next one. Well, we have 70, so that will be one time with a remainder of 10. And then finally, we have the 10s, and here would be our 10, and that will be 10 over 1. So we'll write the Babylonian under each column, very carefully. Well, remember, 1 is equal to that, and 10 is equal to that. So I have a 1 here, I have a 1 here, and then I have a 10. Making sure that I leave a space between each of these because they represent different place values. So that means when I write it in Babylonian without these lines here, it'll just be this, which will be 1 times 3,600 plus this 1 times 60 plus this, which will be 10 times 1. And of course, if we add this all up, 60, 10, 70, we get back our original number, which means that indeed we did that correctly. So our final answer in Babylonian is this, and this, written across like that.
Reviewing what we just did on the whiteboard, here we need the next place value, 60 squared, which is 3,600's place. So 3,600 minus 3,670 leaves us with 70 as the remainder, which is 1 in the 60's place and 10 left over for the 1's place. Here is the 1 in the 3,600's place. Here is the 1 in the 60's place. And here is the 10 in the 1's place. There was a problem with the Babylonian number system. It does not have a symbol for 0. Because of this lack of a 0, the symbol for 3,601 would have looked the same as 61. Both have a 1, then another 1, but 3,601 would have a space in between. It would have been hard to tell if you had a space or not. So here is an example where we have 3,601, and there's the space. And then here is 61. Same symbols, but how do you know whether the space is for 3,601 or the space is for the 60's place and the 1's place? This lack of a 0 seems as if it would have been a big issue, but Babylonian society was a much smaller society. Around 40,000 people lived in their largest city, as opposed to over 8,500,000 people in New York City today. With fewer people to keep track of, it is likely that Babylonians were able to tell whether their neighbor had 61 great cubits of land or 3,601, or whether there were 61 goats next door or 3,601 goats. And so this lack of a 0 may not have been an issue for them. Thank you very much. I hope you enjoyed this video. Take care, be well, and goodbye for now.